Hello dear students. So today we shall go for the fourth module, that is hydraulic machines. So the liquid that comes out in the form of a jet or a jet from the jet nozzle, which is fitted in a pipe through which the liquid will flow under the pressure. So machines will give us the water, or the water that is comes in the form of jet as outlet from the nozzle is called as, or we can say it as the jet that propulsion will be coming out. So for an example, we can say it as our vehicle washing centers will be there, where the vehicles have been washing with some fitted with a nozzle to the pipe, and the water will be flowing through the jet with some force. So this, if some plate which may be moved or a fixed place. So here we need to study about the jet that is floating or on the plate or on a moving or a fixed plate. So here we need to study the force exerted by the jet on the plate which is under the static condition or under the moving condition. So that is what we need to study here. The jet, the water that comes out with the force, that force which is hit on a plate. So what will be that force? So to find out that force, first we need to understand what is the Newton's second law, that is impulse moment equation. So you can see here this force is obtained from Newton's second law of motion from impulse moment of equation. Thus, impact of jet means the force exerted by the jet on a plate which may be stationary or moving. So here there is a condition that the jet may fall on a stationary plate or on the moving plate. So here you can see guys the force exerted by the plate which is vertical, that the jet is coming and hitting, the plate which is inclined, and the plate is under the curve. So three conditions and three derivations we need to do it here. So second condition here what we are going to see is the jet on a moving plate which is vertical, inclined and curved which is inclined. So from before that we shall see what is impulse moment equation. So according to Newton's law, the net force acting on a fluid mass is equal to the change in the momentum of flow per unit time. So what does it mean? That we have studied in our previous or in our schooling level or in a PUC level, we have studied that the Newton's second law states that force is nothing but the mass into acceleration. But we should also know that the acceleration is nothing but the rate of change of velocity with respect to time. So here you can see dv by dt. A can be written as dv by dt. So this dv by dt of acceleration can be replaced in the force equation, that is F is equal to m into dv by dt. Now, therefore, F is equal to, I can bring this on m inside. So d, that is rate of change of momentum. Momentum is nothing but the mass into velocity. So this equation indicates that that is the rate of change of momentum or a momentum principle from the Newton's second law. So next we shall see from this moment equation. So how the stationary plate acts or absorbs the force from the jet. So that is the first derivation, a very simple derivation, that is force exerted by a jet on stationary vertical plate. Now here you can see the jet with a pipe. This pipe is getting fitted up with nozzle where the jet of water that flows. And here you can see the plate which is fixed, which is not moving, it is a stationary. Whenever the water comes with a force, it hits on the plate and tries to move vertical or the downward direction or upward direction. So the water gets split up. So V indicates the velocity, D indicates the diameter, and A indicates the area of the cross section of the nozzle. So therefore that can be written as pi d square by 4. Now here we need to understand one thing, that is the jet after striking the plate will move along the plate. So the jet, when it comes and falls on the plate, it moves along the plate. When it moves along the plate, there will be a component of forces that is deflected to 90 degree. Hence, therefore, the rate of change of momentum, that is nothing but initial momentum, means before hitting the plate and after hitting the plate. So here we need to take that initial momentum minus final momentum. This momentum is with respect to changing time, so divided by the time. So therefore, initial momentum is nothing but mass into velocity. Final momentum is also nothing but mass into velocity. So initial means initial velocity, final means the final velocity we need. So before hitting the plate and after hitting the plate. So therefore, in this equation, mass is constant and divided by the time. So mass by time is kept as it is, initial velocity minus final velocity. Here, initial velocity is having some velocity, but in the final velocity, the velocity gets reduced or almost becomes zero. So therefore, so mass per time or mass by time can be converted. Here you can see that is density is nothing but mass by volume. So if I want the mass, I can bring on this volume this side, so it will become rho into V. So I'll bring a rho into V is nothing but volume per second. That is mass I can write rho into volume divided by the second. Second means here is the time. So volume per second, that is unit of volume is meter cube and second is time. Meter cube per second is the unit of discharge. So I can write it as rho into Q. So rho into Q I can write it as rho into A into V. So A is the velocity, A is the area, V is the velocity. A is the area of the jet. So therefore substituting mass by time in place of rho A into V. So it will become rho A. Initial velocity will be V, final velocity will be 0. So it will be Fx is equal to rho A V square. Now, rho is the density of water, that is 100 kg per meter cube, 1000 kg per meter cube. A is the area of the cross section. V is the velocity. Now work done is nothing but force into velocity of the plane. So force into velocity, final velocity is 0. So work done is 0. So no work done. The second condition here, the force exerted by jet on stationary inclined plate. Here we need to be very careful. So there we were having velocity vertical 90 degree. Here it is inclined with some angle of theta. So here you can see that is a pipe is fitted with a nozzle and it is deflected with an angle of theta here, and this angle will be 90 minus theta. So therefore here you can see the clear picture of the plate. So how the components will be. So while taking the components, we have to be very careful that I shall show you. So here is this is the vertical element and here is the horizontal, and the force if starts with some angle theta here, which is having an angle here theta. So if I want to calculate this force, that is if this force is F, if I say this component will become F cos theta. So I can write theta as Q. Next, this force will become F sine theta. So the component of this force can be written as F sine theta and F theta. Now taking with the same concept or dealing with the same concept, now we shall go for V, theta and A, angle of inclination. So again the concept is same, that is Fx is equal to mass of a jet striking by velocity, initial velocity minus final velocity. So here rho AV is same from the previous equation. So that is, and initial velocity here you can see that is V sine theta, that is initial velocity, and the final velocity is again 0. So the component of jet of water is getting inclined whenever the water comes and hits or the jet hits. So it moves with an angle of theta. So that component we need to find. It is not 90 degree, but it is inclined at an angle theta. So it will become V sine theta minus 0. So therefore rho A, V into V is V square, sine theta is kept as it is. Now Fx. Now this force has to be, we should take the component force. So this is velocity component and here we are taking the force component. So force component Fx is equal to Fx cos 90 minus theta. So here you can say that is the resultant force or the effects of force I need to resolve in this direction. So here is the Fx, that resultant force. This force I need to take here. So it will become Fx cos, because it is a horizontal. Theta is 90 minus theta. So that value is considered here. So 90 minus theta. So Fx value is introduced here. So rho a v square sin theta cos 90 minus theta is nothing but the sin theta according to our trigonometry. So therefore rho a v square into sin square theta. So Fy component is again same. So here horizontal component is cos, vertical component is sin. So therefore rho a v square sin theta, substituting the same Fx as, and sin 90 minus theta is cos theta. So therefore Fy component will be rho a v square sin theta cos theta. But here we need to notice that the work done again is force into velocity. Again final velocity is 0. So it will be 0. Now coming to the next part, it is force exerted by the jet on curved plate. Now we have seen only the vertical plates. Now we shall see how the curved plate will work. Let a jet of water be striking on the curved plate horizontally. So here you can see the horizontal jet is applied on the curved plate. So here you can see the curved ashed plate. Whenever the jet hits on the curved plate, it tries to deflect. Here you can see the deflected part. So here it is moving with a velocity v. The vertical component is v1 sin theta and the horizontal component is v cos theta. Now this angle, whatever the curved plate is there, it has been inclined at an angle of 180 minus theta. So here you can see the whole is 180, but it is this angle is theta. It is deflected with an angle theta. So this angle will become 180 minus theta. And here you can see the proper arrangement or the proper method to take the components. So how it should be resolved. So component of velocity in the direction of jet. So here is the moving with the direction of jet. So if I want to take the horizontal component, so it will become v cos theta. It doesn't make only with the v cos theta. We need to consider the sign convention. So here you can see the sign convention that this axis will be under the negative. So here you can see x axis will be negative and y axis will be positive. Here it is clearly written. So if we take that component, it will be minus v cos theta. So angle of deflection, I told you that it is 180 minus theta. So component perpendicular, that is v sin theta. This is horizontal, this is vertical component. Again, momentum equation we need to make use mass per second into vx1 minus vx2. So vx1 it is nothing but initial, vx2 is the final velocity. But here the final velocity is inclined and moving with an angle of theta. So initial velocity plus final velocity both are existing here. So Fx is equal to rho av v plus v cos theta. Initially it is hitting with the velocity v and final velocity will be v cos theta, because initial minus final velocity. So minus into minus, that becomes plus. So Fx is equal to rho a v square into v can be taken out as a common. So 1 plus cos theta. So Fy will be rho av. Initial v by 1 is 0. So we are not having any inclined field. So v by 2 will be v sin theta. So Fy is equal to rho a v square sin theta. Negative sign indicates that it is moving downward direction. So next one is jet strikes on a curved plate at one end tangentially. So here you can see that is horizontal, but here you can see the nozzle is tangential. So again the components have been taken here. V, it is v sin theta, v cos theta. Here also it is taken with component. Now the theory part is written is same, that doesn't get changes. So again by using momentum equation Fx, mass per second, initial minus final. So initial here you can see that is v cos theta. V cos theta is the horizontal component because we are considering Fx. And the final velocity, so here will be final will be minus v cos theta. So minus of minus it becomes plus. So v cos theta plus v cos theta, 2v cos theta. So it will become 2 rho a v square cos theta. Now, taking the y component is again v sin theta is here vertical, and this is also v sin theta vertical. Both will be plus, but the formula is consisting minus, so this becomes 0. So anything which becomes 0, the whole term is also again 0. So therefore Fy is 0 and also work done is 0. It is very simple equation to derive. Next is jet strikes the curved plate at one end tangentially and one end unsymmetrical. So it is striking up with a plate which is unsymmetrical now. Again the steps are same. So here we need to see that is Fx. So Fx is again v cos theta minus of minus v cos phi, because unsymmetrical plate means angle of inclination changes. Here it is theta and here it is phi angle. So v cos theta minus of minus v cos phi, because this is minus cos phi and this is plus cos theta. So including that, so Fx will become rho a v square cos theta plus cos phi. Fy will be, that is rho a v square sin theta minus sin phi. Again it is vertical components we need to take. So it is very easy. So again, the force on a flat vertical plate which is moving. So till now we have seen that is force exerted by plate which is stationary. Now we shall see force exerted by the jet on moving plate. So again, the remaining all the this remains same. In this case, we need to strike the plate with a velocity v which strikes with a relative velocity, which is equal to absolute velocity minus velocity of the plate. So here we need to relative velocity, that is initial velocity minus final velocity, v minus u, that is of jet with respect to plate. So again, by using the formula rho a, velocity is nothing but v minus u, because it is a relative. As the jet goes on hitting, the pipe goes on moving, the plate goes on moving. So that v minus u is a relative velocity. So final is at least 0. So it will be v minus u, it will become v minus u whole square. Now, in this case, work will be done by the jet. Yes. So this is very, very important in this derivation, that the jet will be doing some work. That is, the work will be done on the stationary plate. Initially, it will be a stationary plate. As the jet goes on hitting, the plate goes on moving. So work done per second is nothing but force into velocity. So force into velocity is nothing but distance in the direction of force per time. That is, distance traveled by time is nothing but the velocity. So I can consider it as u. Fx is nothing but the u, and that is the displacement. So Fx is already we have derived here rho a v minus u whole square into u. Now the density of water is 1000 kg per mole, and the unit is Newton meter per second or watt, because work done will be in terms of watt. Now here the force exerted by the jet on the inclined plate. So here again it is same as we have done, but here we need to be very careful while taking the component of the forces. So here you can see initial versus final momentum. The components of v minus u will be horizontal, that is Fx. Here you can see that is v minus u sin theta. As from the previous derivation we have seen how did we get this initial momentum. So final velocity will be 0. So therefore v minus u whole square sin theta, and fx is fx cos theta. So fx we have already got, so that will be taken as sin theta. Cos 90 minus theta is nothing but sin theta. So rho a to v minus u whole square sin square theta, and fy will be rho a v minus u whole square sin theta cos theta. So therefore, as usual, the work done is same. So substituting the component of forces, we will be getting the work done. So the next is the last part. So we'll be moving. So again, a force exerted by jet on curved plate when the plate is moving in the direction of jet. So here again it is same initial momentum versus final. So mass here will be mass per second rho a into v minus u. That is velocity will be v minus u. Initial here it will be v minus u, and final will be we should take the component here. Here you can see the component here, horizontal and vertical component. So taking that, minus of minus, it becomes plus. So it will become v minus u cos theta. So taking on the common terms outside, so it will become v minus u taking on outside. So it becomes rho a v minus u, 0 minus v minus u sin theta. So it will become rho a v minus u whole square sin theta. Work done is substituting fx with respect to u. So we'll be getting the same value work done. So efficiency, output minus input here, efficiency. So work done per second is nothing but the kinetic energy. So work done is already we have calculated here, and the kinetic energy is half mv square. So this is from our very basic level, half mv square, that is the kinetic energy. So now mass can be written as rho into a into v. So the v square and one more v, it becomes v cube. So this rho a get cancelled, and the remaining efficiency eta will be 2u v minus u whole square into 1 plus cos theta by v cube. So bringing on this 2, it will become 2 here. So condition for maximum efficiency is, that is d eta by du should be minimum, that is 0. So differentiating this equation again, so it becomes a 0 here. So taking on the common terms outside, and remaining is 2u v minus u whole square is equal to 0. Taking this whole term is kept as a 0. So taking this, differentiating 2u, keeping vu minus u whole square, that is 2 into v minus u, and differentiation of v minus u is again minus 1 because v is constant here. Next, keeping again v minus u whole square as constant, then differentiating 2u. 2u, differentiation of 2u is only 2. 2 is constant, differentiation of u is 1. So this is u by v formula applied. So everything which is kept as 0, equating that, we will be getting a quadratic equation, and this quadratic equation is solved. That is v minus u, v minus 3u is equal to 0. One equation is v minus u, another equation is minus 3u. So therefore v is equal to u and v is equal to 3u. That is, we are getting two terms from this quadratic equation. Substituting v is equal to u and v is equal to 3u in the equation 1 here, in the efficiency equation, because we are finding out the maximum efficiency. So substituting in that equation, we will be getting 2u 3u minus u whole square 1 plus cos theta y, 1 plus cos theta divided by v cube. So v cube is 3u cube. Yeah. So simplifying this, we will be getting eta maximum as 8 by 27 1 plus cos theta. For semicircular veins where the theta is 0, when theta is 0, if you substitute cos 0 as 1, so it will become 1 plus 1. So 8 by 27 1 plus 1 2, that is 16 upon 27. That is the maximum efficiency of the curve